Welcome to this web lecture on sustainability, complexity and assessment. My name is Arjan Kirkels. I'm working at Eindhoven University of Technology. In this web lecture, I'm going to discuss three topics. First, what's sustainability? Second, what is complexity? And third, how should we take that into account when we try to assess sustainability? Now, the first question is, what is sustainability? Well, the most quoted definition on sustainability is the Brundtland definition. And the definition states that sustainable development is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. That remains a bit abstract. We can also look at a bit more practical approach. And for that, we will look at the people, planet, profit approach. People referring to social ethical themes, planet referring to environmental problems, profit referring to economic dimensions. And then sustainable development is a balanced development that takes into account all these three dimensions. The next question is, what is complexity? And in order to understand better what complexity is, we will introduce the different types of problems that we can face. A first type of problem are chaotic problems. These are problems where there is no cause and effect mechanism. For example, you might get caught up in a tsunami. A second type of problem are simple deterministic problems. There is a cause and effect, and often we have direct experience, and based on that we understand what's going on. For an example of this category is baking a cake. A third category of types of problems are complicated problems. Also there we see cause and effect, but the things get much more complicated. You need advanced knowledge. Often you require modeling. And with those models, for example, we can predict what happens under different circumstances. And we can be very good at that. A lot of research that we do is related to that. An example, practical example, is shooting a rocket to the moon. The fourth category of problem structures are the complex problems. And those complex problems have both something of the complicated and the chaotic systems. They have cause and effect mechanisms as well as uncertainty. That uncertainty is an inherent uncertainty. So the general responses that we have as scientists related to uncertainty, we solve that by coming up with better models or measuring harder, coming up with more better data, but it doesn't solve the problem because this uncertainty is an inherent uncertainty. Now, where does that uncertainty come from? For example, complex systems are characterized by many actors. They have different perspectives and different interests. A situation characterized by pluralism. Each will have a different view on what the problem is or what possible solution is preferred. The second element is that these systems typically are characterized by many interacting elements that show nonlinear interactions, making it very hard to predict actually what's going on. And a third element is that these tend to be adaptive systems. They change over time. And that can be due to, for example, learning or decision making or innovation in human societies. So the future society looks different than our current society, and we cannot predict its behavior. What's the relevance for sustainability? Well, sustainable problems typically are characterized by multiple actors, by the many elements. And by definition, it is about changing something. It's about a different system because the current situation is unsustainable. So we do want to see change. And that all makes that especially long-term assessments of sustainability can be characterized as complex problems. The question then, of course, rises how to deal with complex problems. Well, there are different approaches to that. A first one is that you can divide the problem over multiple dimensions. There's a knowledge dimension, what we know, the cause and effect relationships, and on the vertical axis you see the normative dimensions, where we see the stakeholders, the values that they have, how they perceive sustainability, what might be a good future that we long for, and who should be empowered to decide on that. That's a normative dimension. Now, strategies to deal with complex problems will have to deal with both those dimensions. So a primary positivist approach in order to get better understanding of how the system behaves, for example by engineering approaches. A primary interpretive approach where we highlight, clarify what the normative and value dimensions are, and then if you want to make your unstructured problem more structured, you will have to involve both, meaning that you'll have to go for a mixed method approach. Now, what does that mixed method approach look like? For example, it requires envisioning desired futures, and that involves pluralism, multiple perspectives of stakeholders, so multiple visions on that future. It involves to devise interventions that likely nudge the system in the correct direction. It's about systems thinking, experimentation. And you need to take into account the uncertainty. And that relates to approaches like scenarios, uncertainty analysis, robust approaches where you have diversity taken into account. But it's also about trial and error, learning, experimenting, and being reflexive on how you're doing. To summarize, in this web lecture, we asked ourselves 3 questions. What is sustainability? We introduced the concept of Brundtland, people, planet, profit. What is complexity? Typical systems that show both cause and effect as well as an inherent uncertainty. And that uncertainty is the result of many actors being involved, nonlinear behavior, and adaptive systems. And we discussed what effects this has on sustainability assessment. It's about assessing both the values and the facts, about a desired future characterized by pluralism, because we have multiple stakeholders involved. It's about interventions and trying to deal with uncertainties. Thank you for watching this video. I hope you enjoyed it.